While the world argues about when quantum computers will break encryption, a different quantum revolution is already moving through labs, defense contractors, and hospitals. Quantum sensors. They do not run Shor's algorithm. They do not need a million-qubit machine. They measure the physical world with precision classical instruments struggle to match. Magnetic fields. Gravity gradients. Tiny changes in motion. Biological signals at the edge of what physics allows. The headline quantum computer gets the TED Talk. The quantum sensor gets the contract. Today we map why sensors may hit your life before the quantum laptop ever does. Quick clarity. A quantum computer manipulates qubits to solve certain computational problems. A quantum sensor uses quantum states to detect something in the environment. Think of it as the difference between a supercomputer and a microscope. One calculates. One observes. Many quantum sensors exploit the same fragile quantum properties that make computers hard to build, superposition and entanglement, but they use them as measurement tools, not logic gates. That is why they can be smaller, colder in some designs, and closer to field deployment. You are not waiting for fault tolerance. You are waiting for signal to beat noise in a very specific measurement task. Start with navigation. GPS is incredible until it is not. Tunnels, urban canyons. Jamming. Spoofing. Underwater. Space. Militaries and shipping companies have known this for decades. Quantum accelerometers and quantum gravimeters aim to track position by measuring inertia and tiny gravity changes, not satellite signals. In principle, you get navigation that does not broadcast your location and is harder to spoof. Programs in the US, UK, EU, and Australia have funded quantum positioning research for years. In 2026, most of this is still prototype hardware in labs and test vehicles, not a consumer product in your phone. But the trajectory is real. When GPS goes dark, whoever has quantum inertial navigation has an edge. Medicine is the second frontier. Quantum magnetometers, especially devices based on nitrogen vacancy centers in diamond, can detect faint magnetic fields from brain and heart activity at resolutions classical tools miss. That opens doors for earlier diagnosis, better imaging in unshielded environments, and research into neurodegenerative disease without massive MRI infrastructure for every study. Hospitals will not rip out MRI machines tomorrow. But portable, quantum-enhanced sensing could show up in specialized clinics and research settings years before mainstream quantum computing pays off. The value proposition is not speed. It is sensitivity. Seeing what was invisible. Defense is where funding accelerates. Submarines cannot surface for GPS. Drones in contested airspace cannot trust external signals. Quantum sensors for magnetic anomaly detection help find objects underwater or underground. Quantum timing and gravimetry support navigation where radios are liabilities. This is not theoretical whiteboard stuff. National labs and defense primes run field tests. The public sees press releases about quantum computers. The classified slide deck is often about sensors. When analysts say quantum will reshape security, they frequently mean sensing and timing first, computing second. So what is actually real right now? Real 1, benchtop and portable quantum magnetometers used in research labs worldwide. Real 2, government-funded quantum positioning and timing pilots with published milestones, not just vapor. Real 3, Diamond ND sensors you can buy for academic and industrial R&D, not mass market, but not science fiction. Real 4, hybrid systems that pair quantum sensors with classical AI signal processing to pull usable data from noisy environments. Not real yet, your phone replacing GPS with a quantum chip. Not real yet, every hospital running quantum brain scans. The pattern matches what we saw in industrial quantum pilots. Quiet progress. Specific use cases. Measurable benchmarks. Here is the takeaway. Quantum sensors are the underrated sibling in the quantum family. They do not need the hype cycle. They need one measurement to be 10 times, 100 times, better than the classical alternative in a mission-critical context. Navigation without satellites. Imaging without massive magnets. Detection without broadcasting. That is enough to change industries. Your move: watch sensor milestones, not just qubit counts. Pilot contracts in defense and medical imaging. Portable magnetometer specs. Positioning tests without GPS. That is where the near-term quantum economy lives. Tune in tomorrow. We cover quantum networking, how sensors, clocks, and processors start linking into the infrastructure the quantum internet actually needs. Subscribe if you want the future without the fluff.